Problem number 10, we have a large table at the top, and we're told that this table gives us values of f and g and their derivatives. And then we're given another function h, which is f divided by g, and we're asked for the slope of the graph of h at x equals 2. So we see slope of the curve, that's telling us derivative. So it's asking us for h prime of 2. Okay, in order to get this, we need h prime of x. So let's see, we're going to put this right up here. So we got h prime of x. We got a f divided by g, so we have to do a quotient rule here. So I'm not going to write all the x's here. I'm just going to make my fraction bar. Quotient rule says bottom d top, so I'm going to have g and then f prime minus, now top d bottom, we keep the f, and g prime all over bottom squared, g squared. Alright, so we need g evaluated at 2. Alright, so h prime of 2, we'll start with g of 2. So here's g, here's 2. They crisscross at -1. So we're going to begin our numerator with -1. Now we need f prime of 2. So f prime, 2. F prime of 2 is 5. Minus. Now we need f of 2. F of 2 is also 5. So that goes there. And then we need g prime of 2. G prime, 2. That is a 2. Alright, and then down below we have g of 2 squared. So g of 2 is -1, and that's being squared. Now, what does this simplify to? Which of these four options? Well, let's take a look. First, we have -1 times 5, so that's -5. Minus, we have 5 times 2, so it's -10, all over -1 squared, and negative squared is a positive. -5 minus 10 is -15. So our answer is A. Problem 11. For the function f prime is 2x plus 1 and f of 1 is 4. What is the approximation for f of 1.2 found by using the line tangent to f at x equals 1? So we're going back to the writing an equation of a line. So that's our point slope form. Y minus y1 equals m times x minus x1. We're told that x1 is 1. So we have a 1 right there. We're told that the function's value at 1 is 4. This is our y1 value. So we have y minus 4. And now we need our slope. We need the slope of the tangent to the curve at a point. That's our derivative. We're given our derivative. We want our derivative specifically when x is 1. So we want f prime of 1, which will be 2 plus 1, or 3. So we're going to use this equation that we just created to find f of 1.2. So we have y minus 4 equals 3. We're going to put 1.2 in for x. 1.2 minus 1 is 0.2. Still have our y minus 4 over on the left side. We still have our 3 out front. 3 times 0.2 is 0.6. And now we add 4 to both sides. So we have 4.6. So we're going to select C. Okay. And then last on this page we have 12. 12 gives us a piecewise defined function, cx plus d, when x is less than or equal to 2, x squared minus cx when x is greater than 2. Let f be a function which is defined above, where c and d are constants. If f is differentiable, that means it's also continuous, at x equals 2, what is the value of c and d? Okay, so we know that f is continuous and differentiable at x equals 2. If f is continuous at x equals 2, that means when we plug 2 into our function, into both parts, then they have to be equal to each other. That's the only way the function, which is piecewise defined function, can be continuous. So what we're being told here is that c times 2 plus d must equal 2 squared minus c times 2. Alright, so 2c plus d equals 4 minus 2c. And if we move the c terms all together, we see we add 2c to both sides, so we have 4c plus d is equal to 4. Okay, now that alone is not enough to figure out what c and d are. We only have one equation with two variables. We need another equation that also has c and or d in it in order for us to figure everything out. So we have to go back to this idea that f is differentiable at x equals 2. If that's the case, that means if we derive both of these parts of the function, then we can plug x's value of 2 in for each, and those must be equal to each other as well. That's the only way that f is differentiable at x equals 2, if both the top and the bottom derivatives are the same when x is 2. So let's go over here and let's do f prime of x. All right, I'm going to ignore the conditions. We need to focus on this. The derivative of cx plus d. Well, c is a number, so think of c like a 3. If c was 3, 3x plus d, the derivative would just be 3. So therefore, the derivative of cx plus d is just going to be c. All right, and then there's a condition, x less than or equal to 2. Now we have to take the derivative of the bottom part. The derivative of x squared, that's easy, that's 2x, minus, and then the derivative of cx. Well, if that was 8x, the derivative of 8x would be 8. The derivative of cx will be c, and that's x greater than 2. Okay, now, when x is equal to 2, both of these must be equal to each other. So I'm going to go down here, c equals, and I'm going to plug 2 in for x, so I have 4 minus c. Okay, c equals 4 minus c, add c to both sides, so 2c is 4, and therefore c is equal to 2. And if c is equal to 2, I can then go right back here, and 4 times 2 plus d is equal to 4. So that's 8 plus d, so I subtract 8 from both sides. And I see that d is equal to negative 4. c is 2, d is negative 4. We want c plus d. 2 plus negative 4 is negative 2.